In any movement of any object, we have more than one force acting on it. In this video, we're going to learn how to calculate the net force of all the forces. Let's take this example. Here we have four forces acting on the car. They are the push on the car by the man, the friction opposing the motion, the normal reaction force, and the weight of the car. In this tutorial, our focus will be on the horizontal forces that are the push and the friction opposing the motion. This guy is trying to push the car forward. This is represented by the blue arrow. And since the car is on the ground, there is a friction force opposing the motion, and it is represented by the red arrow. Here we can see that the push force on the car is equal to the friction force. And since the force is a vector, we should determine both the direction and the size of the force. According to the figure, the forces are equal, but opposite in direction. If you want to get the net force, it will be equal to the push force minus the friction force. We put the minus because the friction is opposite to the push force, and here we assume that the positive direction is in the direction of the push force. So here we'll get no motion. What if we increase the push force on the car, like in figure 2.6? We have another man pushing the car. Let's assume that each person is exerting a 300 newtons force. So the total forward force for both men will be 300 newtons plus 300 newtons, which is equal to 600 newton. The plus sign here is as a result of both forces having the same direction. So here, if we want to calculate the net force, it will be equal to the total forward force minus the friction force. Let's take the positive direction in the direction of the forward forces and the negative direction in the direction of the friction force. So here we'll have 600 Newton minus 300 Newton, since the friction force is equal to one of the forward forces, and the net force will be equal to 300 Newton. So here the car will move in the direction of the greater force.